Here we go. We have a question, find unique binary string. So you have given an array of strings containing n strings of length n, and we need to return a binary string of length n that does not appear in nums. So we need to return a binary string. Binary string. So first binary string is 0 0. So 0 0 can be our answer. Yes, this is our answer, and it does not present in nums. Then here the substring, the binary string can be 0 0. It is there, so we will not include this. 0 1, it is there. Then 1 0. 1 0 is not there, so 1 0 can be our answer. If there are multiple answers, we need to return any one of them. Then in this example 0 0 0 will be our answer. So I hope you got this. Now let's build the approach. So let's suppose we need to find length 7. Let's take length 6 only. So let me create, so 6 will be very big, but anyways let me create a unique strings of length a. Let me create 6 binary strings of length 6. So I have created 6 binary strings. So we need to find a unique string that does not include in this. So we start with our answer. So first way is to select 0. Then we again select 0. So our string becomes 0 0. Let me write it here. So we have empty string. Then we have two paths, either 0 or 1. Then we again have two paths, either 0 or 1. Then we again have two paths, either 0 or 1. Either 0 or 1. Then we again have two paths, 0 and 1. Then 0 0 0 0 0 0 0 0 0 and 1. Then 0 0 0 0 4 5 6 1 2 3 4 5 6. So first string is this. Is it there? Yes, it is there. So we will avoid this. We will ignore it. Then again next possibility is this. Is it there in our nums? Let me check. This string is not there. So this will be our answer, and we will not go any further. Initially our answer is empty. Then if we find our answer, if we found a possible string, then we store it. 2 3 4 5 6. So this is our answer, and we will just return this. Then if we go on this path or any path, either this path or this path, so we have many more possibility, but we will check. If our answer is empty, then only go in depth, but our answer contain some string, so we will not find any more possibilities. So this is a very simple question. Let's code this. So instead of checking in nums, I will create a set. This will help me to find whether a string is there in nums or not in order of one time. So I have created a set, then string. I will add all strings in it. Then I will simply call an empty function, a function with empty string as a parameter. So void string. So let's call current. So we have two possibility. Either we can append 0 or we can append 1, and we need to store our answer. So let me create a global answer. So one thing to notice here is nums contain n unique strings, each of length n. So it contains two strings of length 2, it contains two strings of length 2, it contains three strings of length 3. So nums length is equal to string length. So we need to find two strings. So we can easily check how many strings are there in nums. This will be our stopping point. So set dot size. If this is equal to current size, current length, so then we will stop it. Then we will check is our current string there in set. If it is already there, we will just ignore it. So we will apply return. If it is not there, we will consider it. So if it is not there in nums, we will consider it. We will consider current string. Then we will return it. Okay, but it will go on every possible path. We need to stop as soon as we find our answer. If answer is not empty, means answer is found, so return back. We don't need to find any more possibilities. So this is on optimization. We will stop there. So let me submit it, and it's saying we missed our answer. So let me write answer here. I hope it will work. Yes. So let me submit it. Yes. Now let's talk about time and space complexity. So it looks like on every path we have either 0 or 1. We have either 0 or 1. So it looks like we have 2 raised to power n time complexity, but this is not the case. Our nums contains n items. Yes. So we will only check for n items, and n plus 1th item will be our answer. So we are only checking for of n items. Then on each path we are also adding some character in our string. So on every path we are also adding some character, so it will take order of n, because string concatenation take order of n. This is for string concatenation. This is for n items. N plus 1th item will be our answer. So this is time complexity. What about space complexity? We have set and we have string. We have recursive stack. So everything will take order of n. And that's it. I hope you have learned something new. We have solved this question. The code is given in the description box. We have also talked about time and space complexity. And thank you all for watching this video.